Okay guys, we're back in the garage today, but today I got something special for you. We're taking this Radio Shack boat
All at Radio Shack.
from the 1990s, not fuel injected or turbocharged, and we're going to take all its 1990s glory of slow crappiness and give it a serious upgrade. Full disclosure, I've already done a lot of work to it. I took out the crappy motor and put in some old airplane parts. I'm more of an airplane guy, not really a boat guy. So I have this brushless outrunner motor that's connected to the geared prop shaft that came from Radio Shack. So first step, I took the motor out. I flipped the motor mount upside down and reversed it. It used to mount up here and here. Now it's pushed forward, flipped upside down, so it still keeps the same angle towards the prop shaft, and the gear is still made up pretty well, not perfect, and it worked okay. But that wasn't fast enough. It's geared. Here you can see I've already switched them out, but in this picture right here, you can see that the gears coming from the motor were small, and then it was on the drive shaft was big. So it was about a 1-to-2 ratio. So the original motor was geared down for torque, but overall top speed really suffered. So what I did was I took the bottom gear off here. This is a 4mm shaft, and I had already drilled out the gear here for this 4mm shaft because the original shaft on the original motor was smaller. So I had to drill this out to fit it on here originally. So it slipped right onto this with some heat, and I took the big gear off this shaft and put it on here. So now we have a 2-to-1 ratio. This is 8 teeth, this is 15, so a 2-to-1 pretty much ratio. So we're getting practically twice the speed out of it. But as you can see in this video, it really didn't change much. I got maybe 30% more increased top end, but still not impressive. It's probably what you would have expected from a Radio Shack boat rather than what it originally did, which I wish I had a video of, but I tore into it before I really got at it. So next up, I took radio parts out. So I took the radio and speed controller out that was in here from the original motor that was driven by a Nikko battery from the 90s, as you'd expect. I replaced it with this ESC to drive the airplane brushless outrunner here. This is a Edo Models 3715-01A outrunner motor. It had a 540 standard classic motor in there that they actually both spin about the same RPMs, I found out after the fact. But definitely more overall power coming from this more modern brushless outrunner. So I could, again, airplane parts. This is all done with spares and trash that I had in an old tackle box. So airplane receiver here, a 5-channel receiver connected to this ESC. This is a Castle ESC. I'm not sure what size, but it made it up perfect with this from an airplane I used to have in it. And since I went with all this digital, I had to switch out the servo that was in there, and a new digital servo that I had hanging around from an airplane fit right in. A little hot glue to fill a little bit of wiggle room, and it works perfect to control the rudder. We still had the original propeller on here, prop shaft, everything going to the geared drive, and it's now geared up instead of geared down. But like I said, still isn't performing very well. It's not screaming. It's not getting squirrely like we'd really wish. So today's project, we're going to be swapping out this propeller with this propeller. I got this from eBay. It's a little bit bigger. This is about a 38mm. This is over 40 millimeters. It's metal. This goes to a 4 millimeter prop shaft. So I got a new prop shaft, and I'm going to eliminate the geared motor here and get rid of this prop shaft, replace it with a flex shaft, 4 millimeters going down to this. I got the coupler that connects directly to the 4 millimeter shaft here. So hopefully we'll get it all hooked up. We're going to have direct drive to this monstrous propeller. We're going to stop sacrificing power here coming out of the gearing. These gears are horribly loud, like you can hear in the video. It almost sounds like a gas engine. And hopefully we get a lot more top end out of it. That's the whole purpose here, is to get more top end and hook it up to our Lipo batteries. Again, I'm working with airplane stuff here. So I got a Phantom. This is from the original Phantom drone, 22 milliamp hours, 20C battery. This is my super duper 35C 22 milliamp hour, 11 volts and 1300 20C discharge rate. So hopefully with this and getting rid of the gear, going in direct drive, we're going to get a little more top end. Let's see if we can make it scream. Okay, here we have the new flex shaft. All this stuff came from Offshore Electrics out of Massachusetts. Awesome guys. They pretty much overnighted this stuff to me. I couldn't believe how fast it came. So this is 4 millimeters here. This is going to connect right up to the motor. This flex shaft will go down through, come out here, and hopefully come out pretty much the same as the original shaft here. This sleeve hopefully can stay, and that'll all be fine. And there's some lithium grease down in there to keep it watertight. Let's hook it up. The old drive shaft out. See the drive shaft going straight down in there into the lithium grease. That's kind of like you'd call it a stuffing box on a real boat. Take this C-clip off the prop here. And with that, the prop will slide off. Get the prop off there. I would have loved to be able to just pop this thing right on, but this is a real hobby grade prop. So they're just a different style of mounting. This would never mount up to the prop shaft, even though they were the same size shaft, just not compatible. So we'll get rid of this little tiny plastic fan, and we're going big boy style. All right. Next, we're going to remove the motor because we have to get this gear off here, and then we'll be able to pop up this mount right here with the bearing in it, and then we'll be able to slide this old shaft right out. There we go. We get the motor out. Now, with some heat, we'll be able to remove this pinion gear off the motor. With a little heat, this will pop right out. Okay, get this gear off. We get the clean 4 millimeter shaft, and this from Offshore Electrics. This end is where your drive shaft goes into. This end will go right onto this. And the couple little set screws there. Now with that on, we're going to come in past this. We're going to have to ditch this. We'll pull this out. Connection will be right here, and the flex shaft will just go straight down in, right out the bottom of the boat. This being connected to this, we don't really need this here. This was really keeping the prop shaft from sliding that way. So it was nice to have the bearing there, but not 100% necessary. I'm just going to pull this. This piece right here just pops right out. Remove this prop retainer piece down here. Now the prop shaft slides right out. Cut the prop shaft out in one piece. That's a solid prop shaft versus our new flex shaft, which is more common hobby grade style. We're going to take this, slide it right through the bottom of the boat. Now I've got this in here, and we're going to continue the plastic sleeve on the inside. Before I do that, I'm going to pack a whole bunch of grease down into the bottom. Grease is definitely our friend here. It's going to be what stops the water from coming through the drive shaft. Okay, so we can see here's the coupler attached to the motor. I'm going to have to cut the drive shaft right about here so it can set into that a little bit, and then we'll clamp that in here, and I'll cut the plastic a little bit further back. One more thing I have from Offshore Electrics is this flexible cable saver. So of course everything vibrates. It's probably going to come disconnected. So this here is a little ring, this little donut that you put on here so that your drive shaft can't fall out and you lose the whole thing in the water. First we're going to connect the motor back to its motor mount so we can see exactly where it's going to land before we cut anything here. The motor's all mounted in, got its two bolts in the back there. This coupler is tight onto the motor, so that's not going anywhere. Now we're going to cut the drive shaft to fit into this coupler right here, and then cut this back a little bit. So if we pull this tight, make sure the drive shaft's all the way tight into the boat there. It looks like we want to cut it probably right where these threads are. So we'll cut it right about there. Now we need to get this on and cut down to length. So we'll cut this back maybe an extra inch off the drive shaft itself. So now we have the drive shaft right up to the coupler. It's ready to be inserted into the coupler. And then we'll use two wrenches, one on this and one on this nut, and it'll crimp the drive shaft in place. And then I think we're ready to go drive it. This collar will keep the drive shaft from slipping out and falling out of the boat should it come disconnected from the motor. So we'll slip that on there. We can tighten that down in a minute. Slip the drive shaft in. Now we're just going to tighten it up. So there we go. No more gear reduction. No more power loss there. Whatever this motor is going to be spinning for RPMs, we're getting it straight down the drive shaft and out the back. So next thing we do, we're going to load this up with grease because that's like our stuffing box down there, and that'll keep the water tight. We might have to create a little platform here for the battery to sit on, depending on where we can possibly put the battery. Try to put it as far back as possible so we really get the front of the bow out of the water for top speed. Now we can button up the radio box, put the rudder back in, connect it to the servo, and then we'll be ready to put on our monster prop. Okay, everything's connected. Direct connection down to the bottom. Rudder's back in, covers are back on. I think we're ready to hook up a battery, see how it spins up before we actually put the crazy prop on. For the time being, I'm using this DX5E. This is from one of my old airplanes. I just kind of have this hanging around, and I hook it up to all sorts of stupid projects. So if this all gets going good, we're going to get a nice 2-channel surface radio. Okay, these wires won't be there, but works pretty good. Let's put this prop on. Can't wait to see it spin. I just wanted to give you guys a look at the new prop all mounted up versus the old prop. What a difference. 1990s Radio Shack right here versus modern technology. Not sure how balanced it is. I got a little wobble, and you can see right in the middle of the sleeve that comes out of the boat, there's a little hairline crack there. So I got some 2-part epoxy here. I'm gonna epoxy it up. I'm gonna coat that entire sleeve. I believe normally these are brass on real hobby grade boats where it comes out here, so that tube is a lot more substantial than this plastic, and this plastic is already cracked. So any imbalance in this, I'm gonna get a lot of wobble out of that. So hopefully it's all tight, and when we get it in the water, it's gonna be sweet. Okay, a couple more things that I added before we go to the water. I put this gusset here on the prop shaft, epoxied that in place, added a couple layers of epoxy around the plastic sheathing that comes around the prop shaft. That had way too much wobble in it, so with this 2-part epoxy encasing it and that gusset that I added in there, made out of plastic, hopefully take a lot of the wobble out. I also added this battery stop so the battery can't slide forward. All the wires are retained. Just a little shelf in there so that the battery will be contained and away from the motor, drive shaft, and everything else. So let's hit the water. Okay, one last thing. Out of some sheets of plastic, I formed these trim tabs. Hopefully they help stabilize at high speeds now that I know the thing rips. So get a little bit of extra support out of these babies. Love it. Okay, you got a pistol grip style transmitter, stick style transmitter in your modified Radio Shack boat, or any other boat, or 2-channel device you're trying to control. Doesn't matter what it is. If you're using an airplane style ESC, they only like to work with airplane style transmitters. If you have a pistol grip with your 2-channel receiver here, you're gonna find that you have to hold this forward to get the boat to not go wild, just to sit there in neutral. If you let go of that, all of a sudden the boat goes full throttle or half throttle, and there's no way to program this to work with this. So here's the solution. Mike's Subworks makes the pie sticks here. It's this little little module that goes between your receiver and the ESC, and it translates the signal from this to make the ESC thing as talking to one of these. You can get these at electricoffshore.com or offshoreelectrics.com, and it'll fix your problem of not being able to program this to work with this. Some other guys with fancy transmitters might have a workaround of changing the rate curves and stuff like that. But if you just have a basic cheapo 2-channel and you're trying to get your old Radio Shack souped up brushless boat going, you need one of these. They cost about 17 bucks. It just goes right in between your ESC and the receiver, and it'll get you going. So problem solved. I sat here trying to reprogram this ESC every single which way, tried changing every setting on this, and no matter what I did, every time I plugged the battery in to arm the motor, I had to hold this forward, and as soon as I let go, the motor started going wild, and it wouldn't. There was no neutral. There was no middle here. It was always holding it like that to keep it from going full throttle, and as soon as I let go, it was crazy, frustrating. So 17 bucks later, Offshore Electrics got me that, and this all works together now. Otherwise, you're never gonna get your cheapo RC ESC to work with any other transmitter besides a stick style, because that's what it expects to have coming into it. I can't believe how fast it is now. If you have any questions, comments, leave them below. I'll try to link all the parts I used so you can do this to your Gamma Ray 2 or any other cheap boat.